Good morning to all. Is my screen and my voice? Is it clear? Test. You write your section and roll number for the attendance. I am going to start the class. Is my screen and my voice? Is it clear? Test. Okay, I am going to start the class today. New chapter I am going to start. It is work, energy, and power. That is my chapter. Okay. And everyone write your attendance in the chat box. If you have any doubt while teaching also, you can test it, test the message, and I will note and I will reply for your doubt. And listen very carefully. I am going to start the next chapter. Our chapter name is work, energy, and power. Do you know work? Previously, have you know the definition of the work? What is work? When we say that the work is done, and for example, you are reading or you are writing, can we say that you are doing the work? What is the difference between the general work and the science work? Generally, we say that I did the so much hard work, right, for the exams. I prepared a lot mathematics. I prepared a lot physics. I prepared a lot chemistry. Like that, you will say. And is this really work according to the physics? Right. Our chapter name is work, energy, and power. Okay, and this is our chapter name. And some are telling that till now the link is not there. How the link is not there? I already provided the link, right? Okay, let us continue the class. What is work, and what is energy, and what is power? In this chapter, about these three terms we are going to discuss. First of all, what is work? Okay, before going to know about the work, then we use this term in day to day life. We use this term in day to day life. We use this term work. Okay, I have to do lot of hard work to pass in the board exams. Like that, members will tell. I read a lot. I do the total homework. Like that, you will say. But is it science work? According to the science, the work is different. Okay, then which is said to be work according to the science, and what is the definition of the work that I am going to explain. And for that purpose, let us see first. Let us consider this is a, for example, uh, this is a car. Okay, toy car. You take it is a toy car, and for this, one child is playing with the toy car, and he connected one thread for that, and he applied the force at here. Like this, he is pulling along the road, and this is the road along which the toy car is moving. He applies the force like this, in this direction along the thread. He applied the force, but the car is moving this side. Okay, the car is moving on the road. Car is moving on the road. There is some angle between the force and displacement. This is said to be symbol of theta. Okay, it is said to be theta, and it is called as angle, right? And theta is angle, is it? We can read it as theta, and it is an angle. Okay, what is F here? F is the force. Okay, F is the force with which the object is pulled, and S is the displacement. S is the displacement. Displacement means the car moves in the forward direction, and theta is the angle. Theta is the angle. Okay, now work formula is what? What is the formula for the work? Theta is angle between what and what? Can you tell what is the angle between? Theta is angle. Angle between what and what? Theta is angle between the force and displacement, right? Force and displacement. And now the work done by the constant force, there is a formula. Work done by constant force, according to the physics. There is a formula that work done by constant force is, right? Work is equal to Fs cos theta. This is the formula for the work. You remember. What is cos theta? What is cos theta? Okay. There is some values are there for the cos. You remember it. It is the formula for the work. Okay. It is the formula for the work. Work formula is Fs cos theta. Fs cos theta. In this, F means force, S means displacement, cos theta means what? Cos theta, there is some value in trigonometry. There is a one mathematics topic will be there. There is the angle between the, based on the angle between the force and displacement, the cos value will be there. For example, cos 0 degree, that value is 1. Theta is angle. Theta is angle. It is measured in degrees. Okay. Now cos 0 is 1. Cos 60 is 1 by 2, and cos 30 is root 3 by 2, and cos 45 is 1 by root 2, and cos 90 is 90 degree is 0. Okay, and cos 180 degree is minus 1. Like this, based on the value of cos, based on the value of angle, cos value will be changes. This you will learn in the 10th class. Okay, and now you have to remember the values of cos. Okay, just you have to remember the values of cos. Just wait for the few minutes. It's not responding properly. The board. Only 1 second. So these are the values of cos theta values. Okay. Now, for example, if force and displacements are along same direction. Okay. For example, here like this we will discuss one case at here. If you have any doubt while teaching, you can test the message. I will reply immediately. Okay. For example, one child is pushing this object. Force applying right side. Okay. Force is applying right side. Object is also moving right side. That means the force and displacements are along same direction. Force and displacements are along same direction. You see, the force is right side. Okay, we are applying the force right side, and the object is also moving right side. That means the force and displacements are along same direction. In this moment, angle is what? Angle between F and S. Anyone can reply in the chat box. Angle between the F and S is what? Angle between F and S. Can anyone tell what is the angle between F and S from the figure? Angle between the F and S is 0. Why? Why? Because the force is right side. You see, F is right side, S is right side. There is no angle between them. Here F is different and S is different. This is the toy car. One boy is connected with that string rope, and it is pulled this side. Okay, but the car is moving on the road. That means the car is displacement is on the road, but the force is this side. There is an angle between the force and displacement. You see the figure, first figure in the cursor, right? And angle between the force and displacement is 0. When angle between the force and displacement is 0, then work is equal to what you will get? Yes, the work is equal to W, work denoted with W. It is the Fs cos theta. Fs cos theta. Theta is what? 0. 0 you write here. Then from here the Fs cos theta formula is there from basic formula. But isme then we wrote theta as 0, then we got as work as Fs. Right, this is the work formula. Work formula is Fs. When why Fs? Here, what about the cos 0 value? Do you know cos 0 value? Previously, I said the cos 0 value. It is 1. Then we have to write work is equal to Fs. Then definition of work. How we will define the work? Okay, define the work. Definition of work. How to define the work? If anybody says what is work, then according to the science, how you will define it? The work is the product of force and displacement, right? Work is the it is the product of force and displacement displacement. The displacement also should be in the direction of force. Displacement in the direction of force. Okay, the product of force and displacement in the direction of force. That means the work definition is the force into displacement, but that displacement should be in the direction of force. Displacement in the direction of force. That means you see here figure, the second figure you see, and here this is the force and the displacement. This displacement is in the direction of the force. Is it right? Displacement is right side and the force is also right side. That means displacement is in the direction of the force. Then in this movement, the work is the product of force, we will say. Force and displacement, we will say. Okay, this is the work formula. Work is equal to Fs or work is equal to Fs cos theta. When we will take the work is equal to Fs and when we will take the work is equal to Fs cos theta. If force and displacements are at certain angle, then we say that Fs cos theta. If the force and displacements are along same direction, that means now for example, this is a object. It is pulled by some person in the right side and this object is also going right side. This object is also going right side with some displacement. Here the force and displacements are along same direction. In this case, we can take the work as F into S only. Because in which direction you are applying the force, on that direction the object is moving. Then that's where we can say that work is the product of force and displacement. You must remember that work may be Fs cos theta, first formula, and the second formula is Fs. When we have to use the Fs cos theta and when we have to use the Fs, you have to use Fs cos theta when force and displacements are along different direction. If force and displacements are along same direction, we have to use work is equal to Fs. Then we have to write the SI unit of the work. What is the SI unit? SI unit of work. SI unit of work is the, you remember, it is a joule. Joule is the SI unit. It is symbol is capital J. Okay, right. You take the screenshot and note it. If you have any doubt, you can ask. Okay. Now I am going to erase this and I will continue. Okay. See this. Previously we got the work formula. Work unit is joule. Okay. How to define the joule? Then we have to write here formula for the work is, previously we derived the work formula is Fs, force into displacement. Okay, work for unit is joule. We take it as 1J is equal, force unit is 1 Newton, and displacement unit is meter. Then we say that 1 joule equal to 1 Newton into 1 meter. How to define the 1 joule? Define 1 joule. We write the definition of 1 joule. Okay, how to write the 1 joule definition? Okay, for that it was very simple. You see the work formula is Fs. Work formula is Fs, force into displacement, and 1 joule is equal to 1 into 1 is equal to 1, you will get here right side. 1 into 1 is 1, and that is 1 is equal to 1 into 1 we wrote. That means when we say that 1 joule work is done, 1 joule is the SI unit of the work. That is, if 1 Newton force, if 1 Newton force, I will give the definition, wait. If a object takes 1 meter displacement, 1 meter displacement, if a object takes 1 meter displacement under the action of, under the action of 1 Newton force, 1 Newton force, force unit is Newton. In the previous chapter we discussed 1 Newton force which acts in the direction of, which acts in the direction of displacement. It was very simple. I will write the, you take the force as 1 Newton, okay? Under this force, the displacement we can take as 1 meter. These two conditions you substitute in the work formula. Work is equal to what? Fs, okay? And then you write F is 1 and S is 1. Then work is also, you will get 1 joule. That means if you apply 1 Newton force on a object, it displaces by 1 meter. then the corresponding work is 1 joule. 1 joule is the work done. Okay. If a 1 Newton force, okay, object takes 1 meter distance under the force of 1 Newton, okay, that force and displacement should be along same direction. Why? Angle should be 0 now. Then only we will take the work formula as Fs. Displacement is right side and the force is also right side. Then we say that angle between them is 0. Then only we write work is equal to Fs. Otherwise, what you write Fs cos theta you write. This is the definition of 1 joule. Okay. And this is about the work formula. The work may be, sometimes work may be 0. Okay. Work may be positive, work may be negative. And now let us see here, when we say that work is 0. Okay, when we say that work is 0, what is the condition to get the work? Conditions to form a work, conditions to do work. According to the science, when we say that the work is done, what are the conditions? The first condition is that force must act on the object. Force must act on the object. If the force does not act, we cannot say that the work is not done. Force must act on the object. And the second condition is that object must be displaces. Object must take displacement. Then only we say that the work is done. Object must take the some displacement, that is in the direction of the force. Object must take some displacement in the direction of force. Then only the work will be there. Okay. When you will get the zero work, when you will get the zero work, आप work zero कब होगा? Okay. For example, you are sitting at some place and you are by hearting one answer. Okay, you are by hearting one answer. At that moment, you will not apply any force. Okay, then we here work formula is Fs cos theta. Okay, for example, if force is 0, you write no one, I am not applying any force. Then what is the work at here? You substitute in that 0 into F S cos theta, we are getting the work as 0. For example, instead of second condition, you take the first condition. The second condition is that if displacement is 0, what about the work? Fs cos theta. F into, in S, in place of S I am writing 0. F into 0 cos theta we will get. What you will get here, the work 0 you will get. For example, the force and displacements are perpendicular. If force and displacements are perpendicular, that means theta is 90 degree. If theta is 90, then what is the work? Fs cos 90 you will get. Cos 90 value previously I said it is 0. Okay, then work is 0. That means in the above three cases the work is 0. What is that? F is equal to 0. For example, आप फोर्स से अप्लाई नहीं कर रहे हैं किसी ऑब्जेक्ट का ऊपर में, उस समय में वर्क 0 है. आप एक बुक पढ़ रहा है, एक कहानी पढ़ रहा है, उस समय में आप कितना काम किया, मतलब आप काम ही नहीं किया अकॉर्डिंग टू फिजिक्स. क्यों काम नहीं किया अकॉर्डिंग टू द फिजिक्स? आप एक क्वेश्चन का आंसर बैठ करते तो, एक प्रॉब्लम सॉल्व करते तो, ये मेंटल वर्क है. ये वर्क में हम लोग फोर्स अप्लाई नहीं करता है, इसलिए वर्क 0 होता है. वर्क 0 होता है, राइट. नेक्स्ट, सेकंड केस डिस्प्लेसमेंट 0. फॉर एग्जांपल, मैं एक ऑब्जेक्ट का ऊपर में, वॉल का ऊपर में फोर्स अप्लाई कर रहा है. वॉल का ऊपर में फोर्स अप्लाई कर रहा है, वॉल का ऊपर में फोर्स अप्लाई करते तो उसका डिस्प्लेसमेंट जीरो हो जाएगा। वॉल का ऊपर में फोर्स अप्लाई करते तो उसका डिस्प्लेसमेंट जीरो हो जाएगा। उसका डिस्प्लेसमेंट, फॉर एग्जांपल मैंने अप्लाई फोर्स अप्लाई कर रहा है वॉल का ऊपर में, वॉल वॉल नहीं चलेगा, मतलब उसका डिस्प्लेसमेंट जीरो हो जाएगा। उसका डिस्प्लेसमेंट जीरो होते तो वर्क क्या हो जाएगा, वर्क भी जीरो हो जाएगा, राइट। द नेक्स्ट केस में सोच रहा है वर्क फोर्स एंड डिस्प्लेसमेंट परपेंडिकुलर है। परपेंडिकुलर मतलब फोर्स ऐसे अप्लाई कर रहा है, डिस्प्लेसमेंट ऐसे है, उस केस में दोनों के बीच में एंगल 90 डिग्री होगा। cos 90 वैल्यू आपको पता है जीरो है, previously I said that is zero, that's why the work will become zero, fs cos into zero. That means in some cases the work may be zero, right. That is, if you not apply any force then the work is zero. If the body does not take the displacement then the work is zero. If angle is 90 degree then the work is zero, right. This is the cases when the work is zero. Okay, I'm going to erase it. Just one question I will ask you, based on the work concept. I will stop this. That is, the question is that, okay, if a body takes 10-meter distance, 10-meter displacement in the direction of, force, if a body takes 10-meter displacement, if a body takes 10-meter displacement in the direction of force, 1 minute I will erase. If a body takes 10-meter displacement under the action of, under the action of 5 Newton force, find the work done on the body. They are asking to find out the work done. Then how we can find out the work done? What is the, but in this question you have to take, they are giving something that in the bracket they are giving force and displacements are along same direction. Force and displacement are along same direction. Like this they give. Then what you will get the work? This is the solution. Can anyone try to get the answer and write the answer in the box, chat box? What they gave in the question, you see, displacement is 10 meters. Right, Sanjay Kerai, the right answer. Displacement is 10 meters. We are applying the force 5 newtons. In this case, how much work you are doing? That is our question. Work is equal formula Fs. Okay. When force and displacements are along same direction, this is the formula. Force is right side and displacement is also right side. Then the work, force and displacements are along same direction. The work formula is Fs. We write here F is 5, S is 10. Then work we will get as 50 joules. This is the work. Okay. Right. And now here some examples I will give where there is no work. Okay. For example, one person carrying suitcase on his hand. Okay, a person carries suitcase on his hand like this, and he is walking on the horizontal road. A person is carrying the suitcase. A person is carrying suitcase on his hand, and he is walking on the road. Then he will apply the force on the suitcase in upward direction. Suitcase is in hand like this. This is the suitcase. He will apply the force on the suitcase in upward direction, but the displacement is right side. The suitcase and he is moving right side. That's why displacement is right side. Now the angle between the force and displacement is 90 degree. Then we say that the work according to this basic formula, if angle is not zero, if force and displacements are along different direction, then the work you have to use Fs cos theta. There are simple, it is very, only two formulas are there for the work. One is Fs cos theta. If force and displacements are at certain angle, force and displacements are at certain angle, force and displacements say not in the same direction. You are applying force in some direction and displacement is in some other direction. It will happens. Okay, the force you are applying this side, displacement is this side, and angle between them is theta. At that moment, the work we say Fs cos theta. For example, you are applying the force right side and object also goes right side. The work is Fs. Just we discussed the two formulas of work. One is Fs cos theta and other is Fs. Right? In this Fs cos theta, theta is angle between the F and S. Theta is angle between the F and S. F is one line, S is one line, and then the angle between them is theta. Based on the angle, right? Here the cos value will be there. Cos values I said all gave already cos values. Cos 0 how much will be there? If angle is 0, theta is 0. And cos 90 is how much it will be there? Cos 45 how much it will be there? You know protractor, this is the protractor. Okay, you see here, this is here on this now angles will be written. This is 90 degree, this is 45 degree, this is 0 degree, like this. Okay, this is 135 degree and this is 180 degree, like this angles will be there, right? And based on the angle value, cos cosine angle will be changes. This will be depends upon the mathematics. Cos 0, if the angle is 0, 1. Cos 45, 1 by root 2. These values you should remember. In the next class, in the 10th class, you understood these values, right? Okay, cos 60, cos 60 value is 1 by 2. Okay, cos 90 value is 0. This is the cos angle. Okay, actually cos theta is what? Theta, for example, this is a tower. You are observing this tower from here. This is your eye, and you join the tower edge to your eye, and this is the base. There is some angle at here between these two lines. This is the angle, and for example, this is y, this is x, this is z. There is a formula is there for the cos theta. Cos theta formula is theta opposite side y by theta adjacent side x. This you will learn in the 10th class mathematics. Okay, right. Okay, remaining we will continue in the next class. I will note the attendance. If anyone not give the attendance, you can give. If you have the doubts, you can ask me in the WhatsApp personally. You can send me. I'm going to close.